Hello. Hello. Hello.
Hello, sir.
Animesh, can you hear me?
Yes, sir.
Okay, it says there's some problem. Just give me a moment.
Okay.
Okay, you can see my camera?
Yes, sir.
Okay, all right, cool. Right, so I think we'll get started with the session.
Yes.
And whoever is joining will join in, and then, anyways, the recorded session will be available for everybody.
Okay,
Okay,
sir.
cool. Oh, this is supposed to be. Okay, I think today's session we will have inverted image of uh, the Arduino board because we do not have the others system present. Okay, so here we are. Okay, cool. So what we did last class was to connect the motor driver board with the Arduino, and we had the motor driver board be rotate one of the motors. The same thing we'll do right now. I hope you've done your robot and connected well and have your robot to go forward, backward, reverse, sorry, right and left. Is that done?
Yes, sir. It's done. We've actually done it like thrice.
Okay, you did it in the class as well.
Yeah.
Okay, so the last class, what we did here on the Hangout session was to
This,
make one of the motors go clockwise and anti-clockwise.
sir, I
That's a
think
program that
both motors also. We also made both motors move, I think.
in the Hangout session.
Yeah, I think so.
Okay, fine then. Well, that if that's the case, then fine. No issues. What I will be doing right now is to just give me a moment. I see somebody saying hi. I'll just send a link to a couple of them who want to join the Hangout.
Yes, sir.
Hi, Abhinav. Abhinav. Okay, Abhinav is Animesh. I think you logged in from two accounts.
No, sir. I've only logged in from one account.
Yeah, that's fine. That's fine. Okay, awesome. Right. So I'm just sharing this program that we done last time.
Yes, sir.
You can see. Okay, this is the program that we had done last. No, not this. Okay. screen share, um, Google Hangouts. No. Okay, cool. So this is the program that we had done last time. Present to everyone. Okay, cool. This is a program that we had done last time. We did initialization of our motor. 4 pins of the the 4 inputs for the motor driver board, which is I1, I2, I3, and I4. We defined it as LMF, LMB, RMF, RMB, which is like left motor forward, left motor backward, right motor forward, and right motor backward. We've connected it to pin number 1, 2, 3, and 3, 4. I mean 3 and 4, and then we've defined all of those pins as output. And then in my void loop, I've asked each of these pins to take different digital states. If I make I1 and I2 high and low respectively, I will have my left motor go forward. If I have I3 and I4 make high and low simultaneously, respectively, I have my right motor going forward. The same thing when I do reverse, which means when I do I1 as low and then I2 as high, I have my left motor go reverse. The same applies to the right motor as well. Now, in a lot of cases, as soon as you connect your motor, whenever there are more than one, see, when something has to be turned on and turned off, there are 2 states, on and off. Likewise, when I have 2 wires, I have 4 states available to it. Or I can say each of the pins can be high or low. In turn, it would actually be, I could make it high, low, or low, high, or high and high, or low and low. So there are 4 states available. So here what happens, when I connect my wire to the motor terminal wires to the connector, I would have probably reversed it, or I would not have checked which makes my motor go clockwise and which connection makes my motor go anti-clockwise. So there are chances that when you write this, copy the exact same code onto your robot, your left motor probably might go reverse, or it might go forward, or your right motor might be going reverse instead of going forward. So it is important for you to individually test each motor, which means when I say individually test each motor, what you could do is you could just run one of these codes and probably just delete each of this entire thing, or you could just put it in comment line so that this entire code gets hidden from the compilation when it's getting compiled. And you could run your robot, run this particular code on your robot and see if your left motor is actually going forward and your right motor is also going forward. If this is happening, great. Then what I would suggest is to probably stop the right motor. How would you do it? Make the right motor go low, the pins to go low and low. You will see that the right motor stops. There are chances that your right motor might be going forward in this case, and your left motor might stop, which means you have actually reversed the connections completely. Instead of connecting where you have to connect the right motor, you would have connected the left motor. Where you're supposed to connect the right motor, you would have connected the left motor. So there are chances that we have not wired it properly. So the wiring is what is actually important. And in this case, you will have to take care of wiring properly. Once your wiring is done, once you run this particular code here, both your motors are going forward, then your robot is set to take more commands from you. Now you know what code makes your robot go forward. So randomly when you upload any code that somebody gives you, your robot will not behave like how their robot behaves. Or all of us cannot have the same kind of behavior, expect the same kind of behavior on our robots unless we have wired it exactly like how each one of us have done. To get to that stage, this particular code will help. When I write this code for the first, in this case, both my motors should go forward when I upload this code onto my Arduino board. High, low, high, low. In case your left motor is going reverse in this code, what you should do is reverse the polarity or the reverse the wire. Where you've connected the red, please connect the black, and where you've connected the black, please connect the red. That is in case of where you will be connecting your motor wires as output. Now I will show this how it is done in the picture. Yeah, okay, I'll just show it in this picture. Oh, I don't have to stop. Okay, so this is the motor driver board that we have. So the motor driver board, as we see it, this is where I connect the power to, and then this is where I connect the what's that called? The motor output, the left motor output, and then this is where I connect the right motor output. Now what we'll have to do is, when I run the sample code, if my motor is going forward instead of going reverse, what I will have to do is I'll just have to reverse. If I would have connected this way, I will have to just reverse this order and connect it this way. So this will ensure that with whatever code I have written, high, low will make my motor go forward. So once this basic set of protocol is established, it's easy for me to start coding how do I want my robot to go. Right? I hope all of you would have done this. In case you have not, this is the right time to ask questions so that we can sort out and solve this particular problem before we go ahead with this class. Okay, then I assume that all of you would have done this. And what we will be doing today is to control the speed of motor. Now I see that the motor runs at a particular RPM. What is RPM? RPM is rotation per minute.
Per minute.
Yeah, rotation per minute. Some say revolution per minute, but I wouldn't say revolution per minute because it's rotating. I mean, it's going about its own axis, so rotation is the right word. So rotation per minute is what we will call it. So this motor is actually a 150 RPM motor. So when I say 150 RPM, it means it runs at 100. It runs goes about 150 rotations on its axis, this shaft, for every minute. But this is not how our motor rotates, because we vary the voltage that we supply to the motor, right? So in this case, this motor runs at 150 RPM only when you supply it with a 12 volts battery. Give it a 12 volt power supply. Because we give 9 volts to this, the RPM drops to somewhere close to 90, somewhere between 90 to 100. So 90 is the word that the most place we have seen, but 100 is the RPM that we take for calculation purpose. So your RPM actually reduces to about 100 RPM, which means as and when your battery voltage reduces, your RPM also reduces. The rotations per minute of your motor reduces, which means if I'm running this at 6 volts, it's not a good voltage for me to run this motor. But if I'm running this motor at about 6 volts, I will see that the motor will rotate only probably about 50 RPM, 40 to 50 RPM rotations per minute. At the same time, that is not the optimum voltage to run. The optimum voltage to run this motor is anywhere between 9 volts to 13 volts. So 9 volts to 13 volts, actually 7 volts to 13 volts is the right voltage to run this particular motor. The motor will run at its most efficient state. Now, in this case, suppose I want to reduce the RPM of this motor while it's in rotation. Can I do it in terms of program? Yes, I will be able to do it in terms of program. I just have to change a particular code on my program, and I will be able to run this particular motor at various RPM, and which can be controlled from the program that I write. Now, why is it required? Not always I will be able to change the battery voltage. I have a constant battery voltage that is about 9 volts. Suppose I want a faster robot, I can go with 12 volts, but that will make my robot the faster robot only. I'll never be able to slow it down. Either I have an option to stop it or run it at 150 RPM. So that's what my high or low, when I indicated to the pins I1 and I2, when I say that, I'm just telling it run at 150 RPM or slow down to 0. Nothing in between. Suppose I want to run it at about 75 RPM, just because there is a critical curve that I have to traverse, the robot has to traverse, or the robot has to compulsorily slow down probably because it sees an obstacle. It's something like our smart cars, the self-driven cars, which has to slow down the car whenever it sees an obstacle or when there's a signal it has to stop. So when all of these things happen, I will invariably have to control the speed of my motor. This is where robotics comes into picture. Now, all this while what we did is simple programming, but when you really want to understand the advantage of robotics or the beauty of robotics, you start applying little bit of small programs here and there, which will actually help you convert whatever little things that you have into beautiful projects. Now here we will look at just controlling the speed of this motor. I just want to run this motor at 100 RPM. Yes. Will I be able to run it? Yes. Will I be able to run it at 50 RPM? Yes, I'll be able to run it. Will I be able to run it at 75 RPM? Yes, I'll be able to run it at 75 RPM. So how do we do it? It's a very simple code again. Now let's look at how that code works and how do we connect our robot. So now I'm not trying to connect two motors to this board and then run this again, which means I've skipped that part where I have connected the motor, both the motors to this and run both the motors at once to see the robot is going forward or reverse. I've skipped that part. In case I find questions about they want that could explain. We have already explained this twice in class and once online. But if, in case you have questions, you can personally connect with me and then I will explain how this has to be done. For now, what we will do is we will write a program to vary the speed of the motor. All right, cool. For this, what I will need is the same motor that I had used, the motor driver, Arduino board, and then a few jumper wires, a battery clip, and then I will also require, what do I require? I think that should be sufficient. A USB cable to program my Arduino. So I'm getting all of them, and I've just got my battery. First thing that I'll do is I'll connect the battery clips to the board. I'm sorry that the board looks reversed because of the mirroring of my camera. I've not got this other software to reverse it, but then I think that should be fine. So for now, because it's not the first time we're doing, so I connect to the positive, I connect the red wire of the battery, and then to the negative, I connect the black wire of the battery, or the negative terminal of the battery clip. And then I connect my battery. I just check before I connect any other component to this. I check if my system is working. So here, when I do this, I will actually want my robot, the light to glow. In this case, it is not. So let me check with another battery. This is not happening. So which means I'll have to get another motor driver, which is working. Quickly do.
Sir?
Yes.
My USB cable seems to be not working. My robot's not turning on.
Have you ensured that the USB cable is connected to the Arduino board?
Sir, maybe. Oh yes, I found the problem. I connected to the wrong port.
All right. I hope it's fixed now.
Yes, sir.
Okay, cool. I'm just getting a different board altogether. This board doesn't seem to work.
3. 1, 2, 3.
So I'll recap the connections that I had done last time, similar to how I done last time. Okay, I got a board. Just putting it here. I'm just taking out this wire and then connecting it to the other one. I hope this board works. Otherwise, I don't have anybody at office to fix boards for me. Okay, the red wire goes to the positive. The black wire goes to the negative. And then I just have to tighten it. And then connect it to the battery to check if it's working. Yeah, it's working. So with my motor driver is fine. I have to connect one of the motors. I'll just connect this particular motor here to pin number. The motor 1, which says motor L1, which is actually referring to motor, the left motor, which is actually controlled by I1 and I2 here. I1 and I2 here. So I've connected in such a way that I'm not using I3 and I4 because I'm just connecting one motor. And then I tighten it. I have to first check if the motor is working, the board is working, and if my pins are fine. So if I have to do that, I have to just take one jumper wire and then connect it between the system. So I'll just take one jumper wire. I'll connect it between 5 volts and then connect it to I1 and I2, I1 and I2. Not happening because of this. It's wrong. Something missing in this board. Okay, sorry. Oh, this motor is not functioning.
Without any. Oh. Holy crap. How is this functioning? Okay.
Motor.
Let me execute.
Yeah. And then tighten this. So the motor is here. And then I see that, okay, the motor goes clockwise. And then the motor goes anti-clockwise. All right, okay. So now I've got the motor here, but then this motor doesn't seem to run at a very high RPM. So will I be able to get a motor that actually runs at very high RPM? Let me just check. Yeah, I have a motor that runs at a very high RPM. This RPM should at least be about 50 RPM motor. So I'm just replacing this motor here with a high RPM motor so that you are able to see the difference in speed. what we actually do to reduce the RPM of the motor is not like how we do our actual fan regulators, like how we control the speed of our ceiling fan or a table fan. We actually put a resistor in between to ensure that the speed varies. But here we may not be able to do it because we are asking this Arduino board to do all the changes. If this Arduino board has to do all the changes, it cannot control it by varying the resistance or by varying the regulator. This can only be done by what we call as a pulse width modulation. Now don't get worked out about the terms, but if you actually look at what pulse width modulation is, very simple. What I do is, now that this motor is rotating at a particular RPM, can you see that the motor is rotating at a particular RPM? Yeah. Now what I do is, instead of having the motor to rotate, I will just do this. So if you see, if I do this very quickly, like very high speed, I see that the motor RPM is drastically reduced. Now the motor RPM has increased. Now the motor RPM is reduced. So what am I doing? I'm actually giving pulses to this particular pin, which is I1. So my Arduino board should be capable of generating pulses at a different frequency. Now when I say frequency, what does that mean? Frequency is how many repetitions or how many times do you give these pulses for every 1 second or for a particular duration of time. So this is measured in a unit called hertz. A unit called hertz, which actually is Hz, named after a scientist. So when I say 1 hertz, it means it is 1 pulse per second or 1 cycle per second. So you would have seen this in, say, when we discuss alternate current or AC voltages, where you will have this value written on a lot of power equipments, which says input 230 volts AC 50 or 60 hertz. So all our power lines are at 50 hertz, which means there are 50 cycles per second. Now I will have to vary this number of cycles per second in this particular case, or I can also say how long do I turn it on and how long do I turn it off. On, off, on, off, on and off. What's wrong? So I do on, off, on, off, on, off. I can do it at a very high frequency, which is like I do a lot of pulses per second, or I do on for 1 second, off for 1 second, on for 1 second, off for 1 second, on for 1 second, off for 1 second. If I do it quickly, and then I also ensure that I turn it on for the same duration of time and turn it off for the same duration of time, then I'm actually doing it at 50%, right? I turn it on for 1 second, turn it off for 1 second. But in terms of motor, it is very easy for you to see, or in terms of a LED, it's easy for you to see when it's 1 second. Probably if I do it at every 100 milliseconds, you will not be able to see it, but you will see that the light is less bright. So what you could probably check out with your ceiling fan is probably, you could turn on the ceiling fan, turn off, turn on, turn off, turn on, turn off. You keep doing this continuously, you will see that the ceiling fan will keep rotating very slowly. Even though your regulator is set at a higher speed, you'll see that the fan is rotating very slow. In terms of something like LED bulbs, like at home, you could turn on, turn off, turn on, turn off, but you'll still see that the LED bulb is on. But somewhere the brightness of the bulb reduces. So this is actually PWM, but it's not as easy as we say we do it with the switches, because these switches that we use at household or home appliances are not meant to be turned on and turned off at the same, at that high frequency. It might just end up getting spoiled. So what we do is we write a program in Arduino to turn on and turn off this particular motor at a particular rate, so that my motor speed will eventually vary. Get it? So I can't just turn on and turn off, like it's like telling my robot to go forward, stop, forward, stop, forward, stop. So effectively, when we calculate speed, which says distance divided by time taken, definitely the speed is less. But we would also see visible jerks. You see the robot going forward a little, stop for a while, forward, stop for a while, forward, stop for a while, which is not a nice thing to see. So that is where we bring in pulse width modulation, where we give pulses to the motor in such a way that it is not visible, but effectively it reduces the speed of the motor, or if it effectively reduces the brightness of the LED, or effectively reduces the functional to extent to which the motor could rotate or the LED could glow. Right? Let's start doing it. Let's see how the program is written.
Sir, can it also increase the like speed of a motor?
It cannot increase the speed of the motor. Why? Because when I give high to a particular pin, the maximum voltage that I can give to that pin is 5 volts because it is digital. Right? So when I say high, low, it is actually running at its maximum RPM. And in case I have to reduce the RPM, I have only option of reducing the RPM to 0 in case of digital write. So what I do is I can only now vary the speed between 0 to maximum full throttle. So anywhere between 0 to 100%, I can vary the speed in between. I will not be able to increase the speed or make it anywhere less than 0. That's not possible. So if I have to increase the speed, the only option that I have is to either change the motor. I mean, that's a different ball game. Another option that I have is to change the battery voltage to a higher voltage. But I will not be able to increase the RPM of the motor programmatically because it is a hardware constraint. It's a constraint physically, not programmatically. You cannot do anything. It's physically, it's not possible to change, no matter what you do, to change the RPM to a higher RPM when the robot is running. Okay. So what we'll do right now, because we did digital write, and whatever you're talking of right now to generate a PWM signal is actually what is called as analog write. Okay, digital write is just high and low. Analog write is anywhere between high and low, whatever values come in between. So when I say 0 to 5 volts, if I want to say generate 2.5 volts, what will I do? I will have to turn on, turn off, turn on, turn off at a equal duration of time. Now it is actually analog write is what we are doing, but let's look at how it's done. Okay. Analog write, when I say high and low, it is just 0 or 1 or 0 or 5 volts or low and high. Now, how many divisions can I make in between? That's the question when I take analog write. When I say take analog write, how many divisions is that I can make when I take an analog write? So this will actually tell you how many different speeds that you can control in this particular motor, or how many different brightness variations that you can give in an LED. Now let's look at analog write. Now when I say I can do 10 divisions, I can do 20 divisions, I can do 30 divisions, these divisions will have to be given in a particular number. In Arduino, this division is about 256 divisions. Okay, when I say 256 divisions, which means anywhere between 0 to 1, there is 256 values that you can give to your system. Now let's look at a simple program. Let's write the program and then we will understand how it is working. It works exactly like how we use digital write, but instead of using digital write, we will use analog write. Okay, and instead of telling high or low, we give that particular value that actually says what has to be done. I mean, what should be the value? Because when I say 0, it is off, low, and when I say 1, it's high or on. So anywhere between 0 to 256, or when I say 0, I'm actually coming less than 1, right? I mean, I'm reducing 1 value. So which means it will be 0 to 255. Anywhere between 0 to 255 will actually make my system go on and off. Okay, now let's look at take a simple program. I will say file save as. Are you able to see my screen? No. Okay. One second. Okay. I'm just sharing my screen right now. And this is what it is. Okay, cool. I will be changing the same code here to accommodate this particular program, so it's easy for you to understand. So what I do is I rename this motor control speed. I mean motor control underscore speed control. I just did a save as file, save as, and then I saved it with this particular name and did save. Okay, I'll just delete a couple of things that I do not require. I will just delete this. I'll delete these two pins, which I do not require. Then I delete this, delete this. I do not even require this. This is my program. What does this program do? It will just make this I1 high. When I make I1 high, what will happen to my motor? My motor will go forward. A simple thing, right? It will make my motor go forward. So let's just upload this code and see what's happening. So which pin am I connected? Have I connected the I1 to? It is pin number 1. But interestingly, what you'll have to also see is yeah, okay. Were you able to see the program that I did just now? Okay, cool. So what is happening here is I am connecting this to pin number 1, right? But in Arduino, not all pins can be used for analog write. Now there is a reason for that. Now, if you look at closely at your system, if you look closely at your system or your Arduino board, there are certain pins which have a waveform like symbol on them. This one here. So pin number 3, pin number 5, pin number 6, pin number 9, pin number 10, pin number 11. These are the 6 pins which you can actually use for analog write. Not all pins can be used for analog write. Okay, so here what I will do is I will change the pin to pin number 3. Okay, int I1 LMF equal to 3. Connect I1 here, left motor forward as if this is made high. Okay, void setup pin mode I1 LMF comma output. Clear? Then I will write. Instead of digital write, I will say analog write where A is small. Analog write I1 LMF comma high. So I cannot write high because analog write actually takes value between 0 to 255. So it can be anywhere between 0. You can write 0, 1, 2, 3, 4, 5, 6, 7, 8, and goes up to say 254, 255. So this is the value that analog write can take. When you say 0, it is as well as writing low, and when you say 255, it is as well as writing high. But in this case, what I do, I have to give some value. So what I'll do, instead of giving high, I will write 255, and let's see what happens to my motor. Okay, and let me just upload this code. I'll just upload this code to my Arduino board. Okay, so and I just upload the code. Compiling sketch, and then it there seems to be a problem. Let me try uploading again. Problem uploading to board. Let me just take an example program and see if that is a problem. It's causing the problem here. Yeah, the problem is with the board. Uh, Two minutes, guys. I'm just getting the board. Yeah, I think it's done uploading. So let me just show you my screen, and you can see that the motor is now rotating. Okay, this is because I had given the value 255, and 255 is actually making it rotate like how it used to rotate. And this is the connection that I've made to the board. I've just connected from the Arduino board. I've connected ground, which is common, and then I've connected to pin number 3 here to I1, and that's what I've connected. Okay, all right. So I see that the motor is rotating, and it's rotating in the clockwise direction. Like whatever happens when I give digital write high, right? That's what happened when I wrote analog write. I mean 255. Now let's see what happens when I write analog write. Let's see what happens when I say write analog write 0 instead of 255, and then upload the code again. It's uploading the code, and yeah, my motor doesn't rotate because it's stopped because I've given 0, which is actually telling digital write low. Okay, now let's just change the code a bit and then see what's happening. So I'll just show you my board here. So instead of giving 0, I will say something like 200, and let's see what happens. If you actually look at it well, you will see that the speed of this motor is reduced. Okay, now quickly I will go change it to 255, and you will see the difference. I changed it to 255, and now you'll see the difference. The code is getting uploaded. The speed is increased. The speed is increased. Now I'll change it to 200, and you will see that the speed changes. Code is uploading. The speed reduced. Let me change it to 100 and see what's happening. I'm not showing you the code because it's difficult for me to swap screens. I'm uploading 100 now. So you see that the motor speed is reduced drastically. Okay, it's come to 1/3 of its speed. Now, if I will be able to do this, I will actually be able to control the speed of my motor from the program, not by the battery, not by changing the motor, but from the program, I'll be able to change the speed of the motor. This is at 100. When I say 100, I'm actually giving you a difference with 0 to 255. I'm running it at 100. And now let me run it at say 50. Let's see what happens. Now 50, very slow. Okay, I would want you to try this out. Try this out for yourself and see how this is going. And then probably I will say again, I will bring it up to 255. High full speed. So this is speed variation, and this is what is analog write, and this is what we will start using in our program to control the speed of our robot. Now we did make the robot go forward, reverse, right, left. We can even make the robot go straight for 10 seconds, take a right turn, and then take a left turn, and then go again straight for 10 seconds. We could make it navigate, and all this happens by our instructions. But now, because of analog write, you can also change the speed of the robot, which means you just have to slow down one of the motors. And the moment you slow down one of the motors, you actually can make the robot go forward, left and right. You don't have to do a reverse or stop the motor. You just have to slow down, which means you want to take a slight left. You just slow down one of the motors, the robot will automatically take a slight left. Okay, so this is for today's class. We wanted to understand how analog write works, and we've done it. So again, changing the program to make it 0. Let's see what happens when I make it 0. It just stops. When I make it 100, you'll see that the speed is reduced. Suppose I want to make it exactly half its speed. What I do is 250 by divided 5 divided by 2 is about 127.5. We use a value 127. We can't use decimal values. Beware of it. We can't use decimal values. I am now uploading it at 127. Let's see what happens to 127. 127 is actually making it go half the RPM. I mean, the half. I mean, 50% lesser than what it used to rotate at maximum voltage. Okay. Now, if you actually go into measuring the RPM with a RPM meter and things, you will actually see that it's not actually the RPM reducing by half, but actually the voltage is reducing by half, which means if you take a multimeter and check for voltage right now. Right now I've kept it at 127, and let's see what is the voltage that comes to the output pin. When I keep it at 127, let's see what is the voltage that comes to my output pin. You see the multimeter here. Just turn on the multimeter. Okay. I just push this out. Bring the multimeter back in the screen. And then let me check what is the voltage that I'm getting when I connect it to this. So you'll see that it's about 3.3 volts. It's in reversed, but you should understand that's the reason my robot is running that way. Now let me just change it to 255 and see what's the voltage that I will get. So it's about 5.93, which actually means my battery is drained out. Let me check the battery voltage. The battery voltage should be very less. Yeah, the battery voltage is about 8.43. Okay, let me just bring a new battery and check if that helps. That aids in changing the speed. It should be. Okay, I just picked up a battery, a new one. And let me just connect it. In fact, you will see that the motor is rotating at a very high RPM. Okay, let's keep it here so that it's visible. I'll just measure the voltage now. The voltage now at the output is about 8.87 volts. This is the voltage at the motor terminals. Now when I reduce this to 127, which means I'm just writing analog write I1 as 127 and then uploading the code. So let me just upload the code and you will see that the voltage is reduced to 4.8, which is almost exactly the half of 8.87. Now, because of this, you will see that the RPM is reduced, but you cannot translate directly the RPM to be reduced exactly by 50%. That's not possible. Because it doesn't mean that if your motor is running at 120 RPM when it's 12 volts, at 1 volt it will run at 10 RPM. No, that is not how it happens. For a motor, there is a starting current and starting voltage required, and then there's there is a window in which it operates. So you will not be able to translate the voltage exactly in terms of RPM, but it's actually not a non-linear curve. I mean, it's not a linear curve, it's a non-linear curve. When I say linear curve, it is not like one step is equal to another step there, or whatever you're doing with the program right now, you can also include analog write instead of digital write and see the difference that it makes in terms of speed control. So this is very important, especially when you have robots where your RPM of both the motors are not same. The RPM of both the motors are different, which means one motor is probably at 99 RPM and the other motor is 103 RPM. So now you know how you can actually programmatically bring both the motors to the same RPM. Of course, you cannot increase the RPM to 103. The motor RPM from 99 to 103 cannot be done like how Animesh asked me. Is that possible to be done? I mean, is it possible for you to do it? No, it's not possible for you to increase the RPM, but definitely you can bring down the RPM of the higher RPM motor to 99. Say probably by making, instead of putting 255, you say 250 or 249 or 48. This again goes with trial and error. There is no precise I mean, it's not that there's no precise calculation. There is precise calculation that you can do, but it's quite extensive, quite intensive, and it usually we end up getting it wrong, at least for the kind of knowledge information that we have right now. But there are equations, there are systems that are available that will help you to calculate the RPM to even not just RPM, rotation per minute, to even as precise as a degree or a minute and an arc. The position could be controlled very precisely. There are algorithms that help it, and that's what is advanced robotics. Now here we are using analog write to control the speed of our motor. Now thank you for being part of the session. If you have any questions, you're free to ask me right now, and we will be ending the session in about another 5 minutes time. No questions? All right. Thank you then. Okay, I hope this was a very interesting session. At least you've got the hang of analog write is used. Okay, thank you for being part of the session. You could leave your inputs on the comments on the YouTube video that we post. You could also subscribe to our channel to be part of this Hangout sessions in future. Not just students from the schools that we conduct, and we even encourage people from outside to also be part of the session. So if you would want to be part of this session, you could subscribe to our YouTube channel, and you will be notified whenever we're doing a live Hangout session. So until next time, we will have, probably will have the session again next Monday, Indian Standard Time, 7 p.m. Next Monday, we will have another session, hopefully. Until then, see you and goodbye.